You all. Very excited to be here today for this webinar. We are going to talk about data residency requirements in AI usage today. And it is quite a new space. We have heard a lot of questions from our customers related to how to do this. So I'll just be shedding a bit of light on that today. I'll share my screen. Is my screen visible?
Yes, Abhishek.
Cool. So the first thing is, what does data residency mean? So data residency, usually you'll encounter a lot of compliance laws and folks working in regulated industries. Like, you must be familiar with this, but fundamentally what this means is, like, where is the data getting stored? Where is the data getting processed? And then what is the compliance requirements that you have? So you have to basically match your compliance requirements to your actual architecture of the product and how the data is flowing through it. So that combination is basically what kind of drives this data residency concept. So the first poll is like, how much of a concern is data residency for your AI initiatives today? Like, I'll wait for like 10 seconds for this poll to go through. Let me know, Deepti, when.
Yeah, I would request everyone to vote. Okay, so last 10 seconds to vote. Few of you have not voted. Then we'll be ending the poll. Okay, so very interesting results. Around 60% of the people here think that data residency is a critical blocker, or it is important but manageable for now. Okay, so definitely the need of the hour, data residency in AI systems. Yeah, over to you, Abhishek.
Cool. So yeah, so the first question to ask is like, has this problem become even more complex or more prevalent because of coming of AI? So there are a few factors that are slightly different in how traditional applications were there, and with the AI systems, what changes. So in traditional applications, like, your APIs used to be deterministic. So if you pass an input X, you're going to get an input Y. So a lot of the times you didn't have, like, we didn't need to do like audit logs of every single API call, because those were deterministic APIs. And oftentimes, like, it might not have that much sensitive data. The second thing was, your application logs didn't have sensitive data, so we were fine to send it out to maybe SaaS providers, or collate all the application logs in one region. So that was another thing that was different. With AI, what is happening is, your tracing data is the kind of code. You don't have code anymore, because the agent is the one that is figuring out the flows, which tool to call, when to call, with what arguments to call, all of that. So your trace data is actually the code, and that becomes like the most important data that you have. And that trace data, when I say, I mean like the prompt and the response data, if you're calling MCP servers or tools, which tool was getting called, and all of that. And this data is like very, very sensitive data. This has actual customer information. This has exactly what happened. So it's very, very important to kind of save this data, and save it in the region in which your customer or your compliance rules wants, basically mandates you. So that is why, like, it's now important that many of our customers are not even okay sending this data to like SaaS monitoring systems like Datadog and New Relic and things like that. That used to be the tracing solution earlier. So this has given risen to a lot of concerns of how do you model these things. And then you also want to trace what happens to a request once they start from the user, then they hit your application, then they go to the model provider. In between, you might have some guardrails, then you get back the response, and then you are calling a bunch of tools or MCP servers, and what happens. So, how do you even trace how this data happened? What exactly happened in a customer interaction with your product? Where do you save it? And how do you view this data later for auditing, for debugging, and things like that? So, that's where the problems come in. I'll highlight a bit of the regulatory landscape that kind of defines these rules for data residency and data in transit. So, for example, GDPR, all of us have heard of GDPR. GDPR basically says that all the data of EU citizens need to be processed in EU, which means that if you have customers in Europe, if you are GDPR compliant, you have to process the data in Europe itself. So that means you can only use models from Europe. You can even save your data in Europe. And then how can you even debug or build additional evaluations and things like that on top of the data? And there have been like hefty fines when companies have violated this compliance rules. Then comes like data localization laws. A lot of the countries have data localization laws. Like for example, India, all the payment data, health records have to be stored in India. They can't go outside India. China, critical information infrastructure data has to be in China. In Russia, like personal data of Russian citizens has to be stored on Russian servers. Then there is this industry-specific regulations of HIPAA, PCI, which basically again lay out a bunch of rules for storing like health-related information, your finance, credit card-related information, all of that. And it is not just where you are storing the data. In many cases, it's also about where the data is flowing through. So there are two concepts here. One is data at rest and one is data in transit. Data at rest is where you're finally ending up storing the data, and data in transit is once it originates from the customer, where does the data flow? So if your customer is in Europe, your servers are in US, the data is flowing from first to, let's say, Europe to US, and then from US to wherever data center your application is in. So the entire path of the flow of data is also important to understand, like who processes the data, all of that. And if you're sending the data to any SaaS provider, you again have to keep in mind that where is the SaaS provider hosted. So a lot of the complications come in here when you're worrying about the exact AI traffic. So this is what I was talking about data at rest versus data in transit. Data at rest is basically all your matrices, all your traces, all your prompt responses, everything needs that you end up saving either in a database or in a S3 bucket or wherever you want to save it. And data in transit will be all your calls to LLM providers. Uh, you can't even you have to be also mindful of if you are saving the another copy of the data for let's say fault tolerance like disaster recovery, the other region where you're replicating the data also has to be compliant with your GDPR or any other compliance thing that you have to abide by. So that's what roughly data at rest and data in transit mean. This is just a brief table of what matters for which compliance act. And depending on in which industry you're working, these things will vary. For example, in GDPR, your data at rest also has to be in Europe, your data in transit also has to be in Europe. There are ways to like bypass these rules, but those are like you have to get very, very strict approval. If you are moving data outside EU, you have to get a very strict approval. So most companies end up abiding by these rules. In case of HIPAA, you just need to like make sure that your personally identifiable information needs to be handled like really, really carefully. There's no like constraint on data at rest or data in transit. Uh, Same for UAI Act, DPDP Act in India, like preferences data at rest should be in India. RBI data localization says that data has to be in India. FedRAM certification means that your data at rest and in transit has to be in the USA. Uh, and DSS Global does not have any strong constraints. But usually for to get compliance in auditing and all, you have to like abide by a lot of these rules. Just curious, are you guys dealing with any of these regulations? And you'll see a short poll pop up.
Okay, few more seconds before we close out the poll. Okay, so a lot of folks in uh, GDPR and HIPAA bucket, as well as a few in financial as well as government sector. So very interesting split between most of the compliance frameworks. But interestingly, we did not get any for so everyone is basically working with one or the other regulatory frameworks. Okay.
That's great to hear. So I'm pretty sure that you're either thinking of or you have thought about this problem in some aspect or the other. So I'll explain an example of a real world scenario. Let's imagine a healthcare company with AI powered diagnostics, which is serving patients globally. And if it's serving patients globally, it will have customers in US, Europe, and then other global areas. For the EU patients, they have to have that the personal data, it should be stored in Europe. So then that means that that company will have to route all its traffic originating from Europe customers through European models and then end up saving all the data in Europe. For US, your PHI must be tightly protected. So which means that in some cases you might not even want to send that PHI data to your models. So then you have to put a guardrail specifically for the US customers and not for maybe European customers. So you have to like also model your application to behave differently for different kind of geographies. And then in the global thing, you can expose the data in a central place, but it should not have PII, PHI. So that is another aspect that will come into the picture. We'll go into a bit of what does it mean for you to actually implement a data residency rules and all. So the things that you will have to take into account is if your application is running in Europe, you are only allowed to use European models. So then your application needs to adapt because you will be deploying the same application both in US and Europe. You will have to adapt that you're able to switch models. You have to keep in mind that which gateway you are talking to and all of that. And then maybe you're applying a different set of guardrails for EU and US customers. And then they will also be constrained on the actual models that you can use. So for example, not all providers will give you like BA compliance and all. So let's say like if Azure is giving you compliance, maybe you can use Azure models in US, but and even like let's say a smaller provider like Together AI in US, but you cannot use Together AI in Europe. So it depends on which providers you're working with, what is the compliance they are compliant with. A lot of the factors will change across continents. And then data at rest, like now that you are storing, you have to store logs of European customers in Europe, US customers in US. How do you end up storing it, then viewing the data, combining them for your evaluation and things like that? So that becomes another problem, that because it's very difficult to go to like four different UIs, browse logs, debug things and all. It's better if you can view it from a single place, but the data at storage is at rest is all segregated. And then you also have to define policies on who can view what data. Many of every single prompt response that is passing through your application is sensitive data. So then the question is like your internal engineers will need access to some part of the data for debugging or to see what happened. So then you have to decide like who in the company can view what data. And this means like almost like saying things like for customer X, I can allow my engineers to see the data, but for customer Y, maybe I cannot allow my engineers, depending on what constraints and all do you have. So this also requires very fine-grained access level into the data that you're collecting. And then you have to prove compliance to regulators, which means that every single prompt response that is going to LLMs needs to be audited, stored, even long-term storage. How do you optimize the storage cost? Uh, if you are able to, if anybody asks you to pick up and point at what happened in this interaction, you should be able to do it even 6 months later. So all those things you have to take care of. And then the third part is like, how do you even, from an engineering standpoint, how do you deploy this application globally, keeping in mind that you are able to configure all these rules from a central place? Because there will be like hundreds of applications in your company. Each application will have, some applications might operate globally, some applications might only be in Europe or US. So then how do you manage all these applications from a central platform point of view and make sure that everybody is being compliant? So yeah, so then would love for you to answer like what is the biggest data residency challenge that you are facing today?
A few more seconds before we close out the poll. Okay, so most of the people are struggling with enforcing regional storage and routing, along with managing third-party AI providers. So these are the leading buckets. And then again, a decent chunk in not knowing where the data flows and providing audits for compliance.
Cool. Yeah, that is what we had also expected. These are the most common problems that we have also heard. And we'll try to outline a solutions to a few of the problems that you have mentioned today. So yeah, so I'll move ahead. So one of the things that at least that we highly recommend, and not just because we have an AI gateway, but also because this is one of the things that almost every single company that we have talked to that faces this constraint and supporting is an AI gateway. Uh, the reason is AI gateway is the single pipe in the company through which you can force every single application team to get their data to flow. And once that flows through that single pipe, you have a lot of flexibility to apply a lot of guardrails, lot of controls, everything on that single pipe. Until you have that single pipe in the company through which all data is flowing, there is no way to enforce any sort of principles or guidelines throughout the company. That is why like AI gateway is one of the fundamental reasons that people take AI gateway is to have that single pipe. And once you have an AI gateway, you can make sure that every application team only is able to talk to models via the gateway. And even then, you can extend it to MCP servers tomorrow, like later half when you start building agents, this will also become an gateway to agents. So you will be rest assured that every single AI traffic that flows in the company flows via this pipe. And here you can apply all the rules. If you want to say like your US applications cannot talk to EU models, you can do that here. If you want to say that PHI cannot be leaked for US patient data uh, through to the models, you can enforce it here without and just make sure and even make sure that there is no bug in the application that is causing you to like break the compliance rules because everything can be set at a single layer. So that is what LLM gateway or AI gateway kind of does. Uh, the architecture that we usually recommend for launching an AI gateway kind of thing is you could have done that. You launch one AI gateway in US, one AI gateway in Europe, and just manage them independently. But then the problem is also of maintenance. Like every gateway will have its own configuration that you have to maintain, you have to upgrade, all of those cycles starts becoming complicated. So we usually recommend that there is one control plane through which you can observe all the gateways that are running in the company if you're running multi-region gateways. And then you just manage things from a single place, like all role-based access control of who can access what models, where is the data going, all of that you are able to manage from one control plane. And then you can have as many gateway planes, like you can have a gateway EU, gateway US, gateway APAC, gateway Australia, and things like that. So all of that you can manage from one place. The thing that at least the route that TrueFoundry has taken and that enables this is we have a concept of a control plane and a gateway plane that I highlighted earlier. All your actual requests go to the gateway plane and then go to the models and MCP servers. So there is no hitting the control plane in the active path of the requests. Everything happens within the gateway in the same region. So your application traffic never hits the control plane. And that gives us the additional reliability also that even if the control plane is down, your gateway plane continues to work. And the moment you change any configuration on the control plane, like you add a model in Europe, you change permissions, anything like that, that is reflected on all the gateway planes. So that also kind of gives you that flexibility of what happens. And then once the data is generated by the gateway plane, you can direct it to any of the buckets in any of the regions. So you can also do that part. So the architecture that I just explained, your control plane is centralized. which has routing rules, access controls, all of that. You can say that route you use users to Anthropic. All of those constraints you can specify in the control plane, and the gateway plane just respects those rules and then starts routing the data to the corresponding models and things like that. You can also say that for you customers apply these guardrails and the gateway will apply it for you. So introducing the TrueFoundry AI gateway uh, that is basically built ground up, taking these constraints into account. That's why we have a concept of a control plane and different gateway planes that kind of enables all of these things. So, for example, like we would usually recommend like putting the if you're operating across EU, US, and other regions, we would recommend putting the control plane in Europe. The advantage of this is like Europe has a lot of data at in transit constraints and all. So because the data flows through control plane and then the goes to the S3 bucket, you can basically put the control plane in Europe and then gateway planes in Europe and US. Your models will be in both regions, Europe and US, and then your application that is talking to the gateway, the application that is deployed in US, only give it access to US models. The advantage of that is even if the application team makes a bug or anything like that, there's no way they can ever talk to the EU models. So this gives you that peace of mind that they can only talk to the US models and the EU application can only talk to the basically US application can talk to US models and EU application can talk to EU models. You can configure that in the gateway layer itself, and that gives you the peace of mind that no matter what the application team does, they can never break these constraints. Uh, then all the data that is generated from the gateway, you can say that all data generated from gateway in US should be stored in the US bucket. And then we will automatically make sure that all the data goes in the US bucket and the EU data goes in the EU bucket. You can even specify things like, let's say you have your end customer who who wants to be GDPR compliant, and they tell you that store all my data in Europe. You're not supposed to send my data anywhere else. In that case, you can even say in the TrueFoundry gateway that for my customer X, store all data in Europe. You can even specify rules like that so that we can help your customer to also be compliance of the rules that they have. I'll just I'll go into the product a bit just to explain how these things work. So basically, you will have like when you integrate, let's say, imagine you are integrating the Bedrock models to the gateway. So you can integrate one Bedrock model provider from your AWS US region and one from AWS Europe region. Even in the US region, you can integrate models from US East and US West, and you can specify in the gateway that load balance between these two models based on latency or based on availability and things like that. And for the Europe models, you can also say that between these two regions in Europe, both the regions do automatic load balancing between the two. So you can define those things. You can also say that your every regional gateway will have its own endpoint. So you'll have like eu.gateway.com, us.gateway.com. Like for example, in our SaaS, we have this 15 regions, each having its own URL. So if you specifically want to go to a certain region gateway, you can choose the exact URL to go to that region. And we also have a EU level endpoint, Australia level endpoint, and like that. Then you can configure like where the data, like every data produced by the gateway, which bucket is supposed to go to. So the thing that I was telling earlier, you can say that US bucket should write to US region. My customer X data should be written to Europe bucket. So you can all of that you can control here. You can also define who in the company can access what data. So you can say like these developers can only access the data from this application, or these developers can only access the data from dev environment. So you can also define that. And then you can also define which data to log and not log. Maybe in some cases, like you don't want to log all the data. So you can also define that. And then you'll have complete audit of exactly who did what changes were made. All of that audit logs come by default to the thing. And then you can also scale to multiple regions. Like for example, our SaaS gateway already comes in multiple continents and all of that. So for you, adding a new region, if you're using the SaaS, becomes very easy. If you're self-hosting our gateway, adding a new gateway is literally a matter of an hour. Like 30 minutes to an hour, you'll have a new gateway running in another region, talking to the central control plane, and you can start configuring and using it. So you don't have to think before going cross region, going and respecting all these data residency rules and all. So that's roughly it. I will just go and highlight a bit of the demo part of things. So for example, here, if you see, this is our AI gateway product, by the way. Like, so you can add all the models. This is where you kind of add all the models. So if you see, like, I've added a Bedrock U account, I've added a Bedrock US East 1 account, an East 2 account, and this is my global Bedrock. So you can add according to that, different models from different regions. Then you can have also different gateways in different regions. For example, I have three gateways here, one EU gateway, one US gateway, and this is like a default gateway, which is like a global gateway. But you can have as many different gateways as you want. You can decide which gateway you want to talk to. You'll get this drop down from right here, which gateway you want to talk to. And then you can also define, like, once you have added all these models and all of that, you can also define things like a concept of virtual models, where you can say that my US model, I don't care if it's US East or US West. So I will add my two US models here, and I will tell that you can distribute the traffic between these two US models based on weight, priority, or latency. So you can create a virtual model called US Claude 4, or you can create a virtual model called EU GPT-4. So then that way your applications will use EU GPT-4, and you give the access to use this EU GPT model only to your EU applications. So you can do that access control of who can access what models. And then your developers will basically use this code snippet to call the models. We'll give you the code snippet. You will call the gateway URL. The gateway URL can either be the EU gateway URL or the US gateway URL, based on which one they want to connect to. And then once they start calling it, you will have all the logs and traces. So basically, you will have this detailed metrics of what is happening, how many requests, what is the cost, all of that you start gathering here. And this will apply for both your models and MCP servers and all of that. And you will also get this request traces. So what I mean by request traces is basically you will get this detailed data of system uh, prompt and response from the model. Now, once you have this data, now the question is that I want to redirect this data. I want to say that my EU produced data should live in EU. So that's where our data routing and data access rules comes in. So data routing, I'll just show you here. So data routing, basically you can define things like uh, if my data is created by these applications or these users, or you can also say that my region of the gateway is, let's say, US East. So you can just say, or let's say US, then direct the data to this bucket. And this is where you can select different buckets. This can be in AWS, GCP, Azure, your own Minio installation. It doesn't matter. So that way, that's how you can define that if data is produced by this guy, go to this bucket. If data is produced by that guy, go to this bucket. So you can do all of that controls here. And then you can also have a default bucket. A data that does not match any of the rules can go in a default bucket. So this is how you can define, like, where the data ends up residing. You can also define that who can access what data in the company. So what I mean by that is basically you can say that, uh, for example, everyone can access their own data. Own data means that the data that they are producing or their own team's data, or you can say that they can access all data where my customer is equals to customer one. So you can also define even rules like that, so that not everybody is able to see all the metrics and logs. You can decide who in the company can see what metrics and logs. So that gives you very fine-grained uh, observability on top of which data you want to see and which data you want to store where. So that is on the side of storing the data in different locations. I'll also show you one more thing, which is applying guardrails. For the example that I mentioned, that in case of EU, you will remove PII, but whereas in case of your US applications, you might not remove PII. So you can add one PII guardrail. So for example, let's say I add a guardrail and I can use an Azure PII guardrail. The moment I integrate one of the guardrails, I can define a rule. So I'll go to here and I can define a rule, something like when my basically when your model is, let's say your EU model, then always apply the PII guardrail. So you can apply this PII guardrail right here. So depending on what you want to do and all of that, you can actually do a lot of things here. That's, yeah, that's roughly from my side. Any questions would love to take?
Hi everyone, if you have any questions, please put it in the chat box or the Q&A section. So there's a question, Abhishek. Can you show how this tool is connected to whatever cloud service you're using? GCP, AWS, Azure, etc. Also, is it possible to use locally, maybe using CNCF tools?
So we ship like a Helm chart that runs on Kubernetes. So you can deploy it on AWS, EKS, GCP, GKE, or Azure AKS cluster, or even on your own laptop. If you want to run using a Minikube cluster, you can do that. But this whole system is like a Helm chart that can be shipped, if that makes sense. I'll paste a few docs links on the chat also.
Okay. In the meantime, folks, we have something for the attendees of the webinar. So let me quickly share my screen. I've put the link in the chat window, but we're offering a personalized data residency advisory session along with a 1 month trial of the AI gateway. So if you are interested, just fill in the form and we'll reach out to you to set up your onboarding, set up your platform, and the team will be here to help you get started with the AI gateway. So let us know if you also want us to take a look at your stack, brainstorm your architecture. Happy to set up a session for that also. Just fill in the form that I've put in the chat window, or just scan the QR from here.
There's a question on the chat as well from Raghu.
Yeah, so
Okay.
the question is, as enterprises move towards centralized AI gateways with regional data residency requirements, how does TrueFoundry think about preventing accidental policy drift, where access rules evolve faster than residency constraints? Yeah, so I guess you mean accidental policy drift, as in the rules that you have configured on gateway don't comply with all the updates that you have in the compliance rules. Is that what you mean? Okay, yeah. So I mean, there's no quick answer to that. We kind of provide all the flexibility on the product for you to be able to configure those policies. So you can even go as fine-grained as a single request, routing to a different region if you want to. Now, keeping it up to date is more like a shared responsibility. Like we can also inform you of changes in GDPR, or in some cases, we can highlight you because we see all the data. We'll put a bit of intelligence also on the gateway to also warn you of things that we think might be violating your data residency constraints. So that is something that is there in our roadmap, but it is a shared responsibility between both TrueFoundry and you who is using the gateway. So that is what I mean. Yeah.